So, very good afternoon. I am Payel Chatterjee, and today I'm going to discuss about the biogas plant, different types of biogas plants, its working, and the advantages and disadvantages. So, starting with what is biogas? So, biogas is basically a renewable energy source that is produced by organic materials. For example, cow dung is there, or any sort of organic waste we can use, we can ferment it, and under anaerobic condition, that means there shouldn't be any presence of oxygen, and we can form this biogas. Now it can be produced by agricultural waste, food waste, animal dung, manure, sewage, and so on. The process of biogas production is also known as anaerobic digestion. As I said, that this entire process takes place in the absence of oxygen. That's why this is also known as anaerobic digestion. Now certain bacteria are used which helps in fermenting our biomaterials. So these bacteria include the methanogens. For example, methanobrevibacter, methanomicrobium, and so on. And the calorific value of biogas, it ranges from 5,000 to 5,500 kilocalorie per kg. Now, coming to the biogas potential. So, biogas potential is mainly the ability of India to produce the biogas in an efficient way. So this biogas technology has a very significant role to play in integrated agricultural operations, rural sanitation, large-scale dairy farms, and sewage disposals. Now it is estimated that cattle dung, when passed through a biogas unit, it yields more net energy than any like like we all know that in village areas even the cow dung is burnt so that it can be used in cooking purposes. But if we, in place of that, if we use biogas, then that will give more result and more outcome as well. Now there are about 250 million bovine, cattle, and buffalo population in India, and one biogas unit for small family require about 3 to 5 cattle heads, which also makes it convenient to use this biogas, because normally in rural areas, in each and every household, on an average 4 5 like buffaloes or cows we can see. Now coming to how this process takes place. Now at the first stage, what happens, the breakdown of organic polymers takes place. Now in this entire process, what we are doing, we are actually producing biogas with the help of the raw materials, that too semi-solid raw materials. So it should go, or it should actually experience a lot of breakdowns so as to make it suitable for the production of biogas. So at first, what is done? The breakdown of organic polymers takes place. For example, carbohydrates, like they are broken down so that it can be available for the next stage, so that the bacteria can work upon the already broken down organic polymers. Now this acidogenic bacteria, they convert the sugar and amino acids into carbon dioxide, ammonia, hydrogen, and organic acids. Now what is mainly done, the complex things, or the compounds which are very complex, they are being broken down into simpler form. Now the organic acids are now converted into acetic acid, hydrogen, ammonia, and carbon dioxide. So they are further broken down into different forms of acids. Now these are at the last stage, these are finally converted into methane and carbon dioxide by the action of methanogens. So at the last, like in the last stage, they are finally converted into the methane and carbon dioxide. So what is specially, or what is specifically being, we can see, like what is specifically being done is that in each and every stage they are being broken down continuously. Like first they're broken into organic polymers, then again they're broken into this carbon dioxide, ammonia, then again they're broken into acids, and then finally they're like we can get the gases. Now we should know that the mixture of the biogas which we get. So the biogas is a mixture containing 55 to 65% methane and 25 to 45% carbon dioxide. So basically this, as I already discussed before, that this biogas can be produced from the decomposition of animal, plant and human waste. And also this biogas is produced by digestion, where the complex compounds, they are being broken continuously in each and every stage. And it is also a biological process, because as I told you, these methanogens, these methanobacteria, they all are organisms which are working upon the our this organic materials. So basically this is entirely a biological process. And also we have to keep in mind about the pressure and the temperature. So in this entire this biogas plant, the temperature is 35 to 70 degrees Celsius. So now let's come to the working of anaerobic digestion. So mainly the digestion or the decomposition and fermentation, they take place in the anaerobic digestion. So digester basically is a part of biogas plant. Now there are three major processes that takes place inside this anaerobic digestion. So the first one is enzymatic hydrolysis. So as the name suggests, like as we all know, that hydrolysis means breaking down of any complex compounds. And what is enzymatic? Enzymatic means when these compounds are broken down with the help of some sort of enzymes, that is known as enzymatic hydrolysis. So what is done in this stage? A group of facultative microorganisms acts upon the organic matter and converts insoluble complex high molecular compounds of biomass into simple soluble low molecular compounds. So what are facultative microorganisms? These are basically those microorganisms which like helps in breaking down the complex compounds in the presence of oxygen, but they can also carry out this entire process of fermentation without the presence of oxygen. As I already told you, that this biogas entire process is also known as anaerobic digestion. So these facultative microorganisms, they helps in breaking down these complex compounds even in the absence of oxygen. So the organic substrates such as polysaccharide, protein and lipids, these are converted into simpler forms: monosaccharide, peptide, amino acids and fatty acids. Then after that, they are further converted into acetate, propionate and butyrate. Now the first stage is done, the first process is completed, then it goes to the second process, which is acid formation. Now these microorganisms of facultative and anaerobic group, they collectively known as they are known as acid formers, because in this acid formation stage, the end product which we get, that is acids. So since these microorganisms, they are converting this acetate, propionate and butyrate into acid, that is butyric acid, propionic acid. That's why they are known as acidogens. So what is done here? The microorganisms, this I have already told. So in this, the water soluble substances are converted into volatile acid. The major components of the volatile acid is the acetic acid. In addition to acetate or hydrogen and carbon dioxide, some other acids like butyric acids and propionic acids are also produced. So we can see that in the first stage we got acetate. In the second stage, that acetate is converted into like several different forms of acids, like this propionic acid, butyric acid. So here the second stage gets completed. Now let's come to the third stage, that is methane formation. This is the final stage where we actually obtain the methane gas. So this acetate or hydrogen plus carbon dioxide, they are converted into gas mixture of methane and CO2 by the bacteria, which are strictly anaerobes, because this entire thing, they takes place in the absence of oxygen. So the organism that works upon them, they are known as anaerobes. Now these bacteria are called methane fermenters, because they ferment the acids that are formed and they convert it into methane, that is our end product. That's why these are known as methane fermenters. So for efficient digestion, these acid formers and methane fermenters must remain in a state of dynamic equilibrium. That means that both the processes, the reverse process and the process that is going on, that should go like in an equal position to each other. There shouldn't be any difference between the two processes. So we should like these two remain in a dynamic equilibrium. Now the remaining indigestible matter is referred to as slurry. Now the part which we obtain after we are obtaining the gas and everything, the waste that gets remained at the end, that is known as the slurry. So now here are the, again, as I discussed before, these are the raw materials like animal dung, poultry waste, plant waste, human excreta, industrial waste, and domestic wastes. So we can use all these to form the biogas. So this is a very a basic diagram of biogas plants. So here I can also mention the parts of the biogas plant. Like the first one is the slurry tank. This slurry is a mixture of cow dung and water. So we put this mixture in the slurry tank. Then this is an inlet pipe. Through the inlet pipe, this mixture of slurry, that is the mixture of water and cow dung, it goes to the digester. I just explained the entire three processes. So those three typical processes, they takes place inside this digester. And then there is a gas holder above this digester. So this gas holder is the place where the gas gets stored. After the biogas is formed, then the biogas gets stored in the gas holder. Then from this gas holder, through the outlet pipe, it goes to the, like, several connections, like in our kitchen or in industries or wherever it is then further needed to be used, it goes to there. Now there is also a sludge. Now what is the sludge? As I mentioned before also, that after extracting the biogas from the cow dung or from the slurry, when we are done extracting the biogas, then the remaining waste that goes to this sludge tank. Now this remaining or this waste, it contains high amount of nitrogen. So it is an excellent manure for our agricultural field. So we can also, like, we can recycle and we can use the end product also by wasting it less. So it is kind of also like it is helping in the sustainable agriculture. So here the, as I already discussed before, so these are the main features or the main parts of biogas plant. So there is slurry mixing tank, so where the dung is mixed with water. Here is digester where the fermentation takes place, that too like in the absence of oxygen. So this is also made up of bricks and cement mortars. It holds the slurry within it for the period of digestion for which it is designed. Now, the third and the most important part is the gas holder. As I told you before, this gas holder is the place where the gas gets stored. And when I'm going to discuss about the types of biogas plant further, so there this gas holder plays a very important role, because the difference or the different, like, we are getting this different types of biogas plant solely on the basis of this gas holder. Like there are two types of biogas plant. One is floating drum, and another one is fixed dome type. So these two are mainly depending on the gas holder. Like in one structure, the gas holder is floating. So that's why that type is known as floating drum. And the another one, the gas holder is fixed. That is, it cannot move. So that is known as the fixed dome type. So mainly the difference is done solely on the basis of this gas holder. Now, the outlet tank and slurry pit. So this slurry pit is also known as sludge tank. It is also known as outlet tank, where we keep the waste which we get after getting the biogas. So now, as I already mentioned, there are two types of biogas plant, the fixed dome and the floating type, solely depending on the position and the type of the gas holder. So this is a fixed dome type of biogas plant. Almost all the parts are same. The only difference between these two is that in the fixed dome, the gas holder is in a fixed position, which is made up of bricks, and it cannot move. Whereas in the floating type, the gas holder is made up of metal and it can move up and down on the basis of the biogas contained in it. So this is the construction of the fixed type of the fixed dome type of biogas plant. As I already mentioned, mixing tank, inlet, digester, outlet, and overflow tank. All the parts are similar. So now let's go to the working of fixed dome type of biogas plant. As I already mentioned, the working of the normal biogas plant, it is completely same as the normal working. Just the difference again is about the gas holder. So it is the various form of biomass are mixed with an equal quantity of water. This is known as slurry. This slurry is fed to the digester through inlet chamber. Then the plant is left unused for about 2 months because the fermentation process that takes a lot of time. Now during these 2 months, the anaerobic bacteria present in the slurry that decomposes or ferments the biomass in the presence of water. Now, as a result of anaerobic fermentation, biogas is formed, which starts collecting in the dome of the digester. As more and more biogas starts collecting, the pressure exerted by the biogas forces the spent slurry in the outlet chamber. From the outlet chamber, the spent slurry overflows into the overflow tank. So, as we get a lot of amount of gas, so what happens that when a force is applied by the gas, the remaining sludge that comes out and that gets collected in the outlet tank. The entire working is same. So the spent slurry is manually removed from the overflow tank and used as a manure for crops in the farm. The gas valve connected to a system of pipelines is opened when the supply of biogas is required. In the outlet valve, there is one control through which we can control the flow of the biogas and according to our needs and requirement. To obtain a continuous supply of biogas, a functioning plant can be fed continuously with the prepared slurry. If we want a continuous supply of biogas, we have to continuously keep that biogas plant. We have to keep feeding this slurry. So what are the advantages of fixed dome type? This is very easily like the materials, they are easily available because that is made up of bricks and cement, nothing else. So it is easily available. It is low, the cost is very low. It is having a long lifespan because it is completely a brick structure, so the lifespan is more. Absence of any moving part, this is a very big advantage. Since there is no moving part, so there is no any chances of corrosion, or we have to change the part, or like these sort of problems are not there. So underground construction saves space and protects the digester from temperature fluctuations. Also, these biogas plants are normally situated under the ground because this fermentation process, this requires a constant temperature which we cannot get above the surface. So this entirely takes place inside the ground, so there is no temperature fluctuations also. And local construction provides opportunities for skilled local employment. Now these can be made by local laborers, so also it enhances the employment. Now, what are the disadvantages? That certain specific technical skills are required to ensure a gas tight construction. So to make it gas tight, some sort of technical skills are required, because if the gas starts leaking, then it will actually hamper the entire biogas production process. Then special sealant is required. Obviously, we should plaster it with a proper sealant so that the gas doesn't leak. The gas leak may occur when not constructed by experienced masons. So we have to also hire experienced laborers. Fluctuating gas pressure depending on volume of stored gas. Like there might be fluctuations in gas pressure. Difficult to construct in bedrock, like if our surface is very hard and if it is covered with a hard bedrock, then it is very difficult to make this biogas plant in those type of places. And also once constructed, it is difficult to repair as the reactor is located under the ground. Since this entire structure is under the ground, so it is very difficult to repair it. Then again we have to dig it and we have to do a lot of things to correct it. Now let's come to the floating gas holder type of biogas plant. So in this floating type, the parts are again completely same. Mixing tank, as I told, digester tank, inlet pipe, outlet pipe, gas holder and overflow tank. Here the only difference is that the gas holder, it is an inverted steel drum. As I told, this fixed dome, everything is a brick structure. But here, the gas holder is made up of steel drum that is resting above the digester. Now, the drum can move up and down, that is float over the digester. The gas holder has an outlet at the top which could be connected to gas stoves. Now, what happens in this floating drum type? Since the gas holder, it is made up of metal structure and it can move. So, it moves solely on the basis of the amount of biogas kept in it. If the amount of biogas is too much, then when it becomes heavy, then it goes up. When it is empty, then it again comes down. So like this, the gas holder, it is movable. So how does it work? Exactly, the working is completely the same. The only difference was that of the part of the gas holder, which I already explained. See, as I told, biogas being lighter rises up and starts collecting in the gas holder. The gas holder now starts moving up. Now, the gas holder cannot rise up beyond a certain level. As more and more gas starts collecting, more pressure begins to be exerted on the slurry. The spent slurry is now forced into the outlet chamber. All the process is same, the only difference is in the gas holder. When the outlet chamber gets filled with the spent slurry, the excess is forced out through the outlet pipe into the overflow tank. So this gas valve, again, here is also a valve which regulates the flow of the biogas. And also, if we want the continuous supply of gas, we have to again fed the biogas plant with continuous slurry. Now the advantages are it is simple and easy operation. The volume is like directly visible as the gas holder is going up. So we can easily see the volume of gas. If the gas, like through the by the movement of the gas holder, we can understand the amount of gas present. Like if the gas holder is above, that means it is having considerable amount of gas, and if it is down, that means the gas is not there. So we can easily monitor it. Like constant gas pressure can be obtained, relatively easy construction, and construction errors do not lead to major problems in operation and gas yield. Now, what are the disadvantages? It is quite expensive because movable parts are there. Then again, this metallic structure is there. Then it is susceptible to corrosion as steel part is there. So it might be susceptible to rust. Now, hence, floating drum type biogas plants have a shorter lifespan than fixed dome type biogas plant. Obviously, because since it is like containing one metal drum, so its lifespan is also less, requires regular maintenance, and also regular maintenance costs for the maintaining of the drum is more. Like we have to like monitor and we have to like keep the drum in a very nice way. Now one of the type of floating drum type is this KVIC biogas plant. So it is most popular KVIC, like it is the most popular biogas plant. In 1945, scientists of IARI have like worked, and in the years 1961, this Khadi and Village Industries Commissions, they patented the design, which is being popularized by various agencies in many countries. So what is different in this? That the gas holders, they're made up of a bit more high material. They're made up of fiber, reinforced plastic, and ferrocement. They are being used. And the only difference between the like normal floating drum type of biogas plant and this KVIC biogas plant is that there is one wall. A wall is there in the digester, which separates the gas. The biogas is separated by one this wall. So there is one, see, it is mentioned here. The design consists of a deep well-shaped underground digester connected with inlet and outlet pipes at its bottom, which are separated by a partition wall dividing the 3/4 of the total height into two parts. So that is the only difference. The rest is same. This is a model of a KVIC biogas plant. Now, these are the advantages and the disadvantages. Advantages are the constant gas pressure, minimum gas leakage, scum problem is minimum, pressure is equalizes, no danger of mixing. This is the most important thing, that there is no danger of mixing the biogas and external air because one wall partition is there. So there is no danger of explosion. Now, the disadvantages are it is of higher cost since it is more advanced. So it is having more maintenance cost. The outlet pipe should be flexible and heat is lost through gas holder. Now, these are some types of fixed dome type of biogas plant, which includes Janta and Deenbandhu. So, Janta, it is by Gobar Gas Research Station, Ajitmal, in view of its reduced cost. This is a plant where no steel is used. There is no moving part, as I already mentioned, and it is constructed by village mason also. And Deenbandhu is also one type of fixed dome plant. It was developed in 1984 by Action for Food Production. It is a voluntary organization based in New Delhi, and it is also like made in the purpose of this reduced cost, because in villages we all know that the condition of villages are not that well. So these models are mainly to make it convenient for the villagers to install it. That's why it is also like this Dinabandhu and Janta, both being fixed dome type of biogas plant. They don't have any movable part. They don't have any steel part. They are solely made up of bricks and cement. So here are some differences between these three. Like KVIC is the floating drum, Janta and Dinbandhu are the fixed dome. So here is one difference between these three. Like in KVIC, the digester is a deep well-shaped masonry structure. Plants, a partition wall is provided in the middle of the digester. As I said that in KVIC partition wall is there. In Janta, there is no partition. In Dinbandhu also, there is no partition. Now, the gas holder is generally made of mild steel. As I told that KVIC, the like gas holder, it is movable. So it is made up of mild steel. In Janta and Dinbandhu, the gas holder is made up of a masonry structure. That is, it is made up of cement and bricks. So there are no any movable part. Now, the third one is the gas is available at a constant pressure of about 10 centimeter of water column. As I told you that being a little more advanced structure, this KVIC, we can get a constant pressure. But in Janta and Deenbandhu, since these are fixed dome type, these are sort of like traditional structures. So they don't have any constant pressure. The gas pressure, it varies from 0 to 90 centimeter of water column in Janta, and it varies from 0 to 75 centimeter of water column in Deenbandhu. Now, the inlet and outlet connections are provided through asbestos cement pipes, but in Janta, the inlet and outlet tanks are largely masonry structures. As I said, that here is no steel. These are fully made up of cement and bricks. And in Deenbandhu, the inlet connections is through AC pipe. The outlet is a large masonry structure. And also this is designed to store slurry displaced out of the digester with the formation of gas. So now the further differences are that the gas storage capacity is 50% of the gas produced per day in KVIC. Then it is a combined volume of inlet and outlet displacement chambers, and the 50% of the gas is stored, which is produced per day. And in this, and like in Dinbandhu, it is the volume is 33% of gas produced per day. Now, again, since the floating drum, it is made up of mild steel. So in case of this KVIC, regular care and maintenance is very much necessary. But in case of this Janta, there is no moving part. So no need of like everyday maintenance. And same goes in the case of Dinbandhu. Again, the installation cost is very high in case of KVIC because it is very advanced. It is cheaper in case of Dinbandhu, and it is most cheap in case of the this Dinbandhu. In Janta, it is cheaper than the KVIC, and Dinbandhu is the most cheapest one. Now, in case of this KVIC, the digester can be constructed locally, but the gas holder needs sophisticated workshop facilities because the entire construction is same. The entire thing is made up of bricks and cement. So the entire structure can be made easily by anyone. But in case of this KVIC plant, to construct the gas holder, special people should be hired, those who are having a proper knowledge about how to place it, because that is movable and that requires more knowledge. In case of Janta, entire plant can be built by a trained mason because there are no movable parts, there is no steel parts, entire is made up of this cement structure itself. And in case of Dinbandhu also, the entire plant can be built by a trained mason using locally available materials. So these are basically the difference between a fixed drum and a fixed dome and a floating drum type of biogas plant. Thank you.
Thank you, Ms. Payel, for the detailed presentation. Now we'll take up some questions.
Okay, ma'am.
Okay, so there are some basic questions now. What is biogas plant?
Ma'am, so biogas plant is a structure. It is basically a structure under which, as I told, that the raw materials, which includes the organic raw materials, those are converted into biogas, like methane and carbon dioxide, which can be used in cooking or in industrial purposes. So basically, biogas plant is a structure which converts the organic raw materials into biogas.
Okay. You can stop sharing the screen.
Okay, ma'am. Just
Yeah. Yeah. Next question is, how does biogas plant produce energy?
Ma'am, as I mentioned, that the biogas is the end product, and normally in the village areas, people still, even there are so many areas where people uses this cow dung to actually produce the gas which they use for cooking. But in case of biogas plant, what we can do is that we can connect it to the kitchen and to the places where the where the work is done, and what we can do is that we can cook by using this biogas. Like as we use CNG, right, this compressed natural gas, so it is just an alternative to CNG. Like we can use biogas for cooking purposes instead of the CNG, which is like, since biogas is a more cleaner fuel, so that's how we produce energy through biogas.
And how does biogas contribute to renewable energy production?
As I already told, that the biogas production takes place solely by fermenting the organic material. So, firstly, inorganic materials are not used. So, it somehow it reduces the pollution. Even when like we are using CNG, we are actually contributing to a major air pollution. But if we shift to biogas, which is completely obtained from organic materials, so we are actually limiting or we are decreasing the carbon footprints to a very high extent. And also, after getting the biogas, the sludge, which I already talked about, the sludge, we can also use it as manure in our agricultural field. So if we see through the perspective of a farmer, everything what he is doing is from his own field. Like firstly, he's taking the cow dung from his own cows or from the or from the livestock which he's having. Then he's producing the biogas. The sludge which he's obtaining, he can again reuse it in his own farm. So it is kind of a very renewable source of energy.
Okay. And what are the main components of biogas plant?
Ma'am, so the main components of biogas plants, as I mentioned, is that the first is the slurry tank. The slurry is the mixture of the cow dung and the water, which we have to put so as to get the biogas plant. Then that slurry goes to the digester tank, where I already mentioned that the three processes takes place, and the mainly the fermentation and the decomposition takes place in this digester. Then there is a gas holder. So after the biogas is formed, that gas is stored in the gas holder. Then there is an outlet pipe which contains one valve. So that valve is the control valve where we can control the amount of biogas which we need in our household. And then this outlet pipe, it goes to our connections of our home. And there is also one sludge tank which is also known as the we can also call as the outlet tank, where the spent slurry, that means the slurry which is already used to produce the biogas, that is stored, which contains nitrogen and which can be used in manure. So these are the components of biogas plant.
Okay. And are there any challenges or limitations associated with it with biogas production?
Yes, ma'am, there are actually a lot of challenges. The first challenge being that the initial cost of construction is quite high. And people also the villagers, they also worry about installing biogas plant, because since it is an underground structure, so the maintenance cost is high. And also if any part gets if it gets broken or if it gets damaged, then it's very difficult to actually correct it because the entire structure is underground. And apart from that, people are nowadays, they are so much used to this CNG or this LPG, that they are kind of initially they are very much hesitating to adopt to this KVIC biogas plant. And also it is completely and solely it is limited to village areas, because we all know that the organic materials which we are getting, it is solely from the cow dung and and from the waste materials. So it is very difficult to actually think about installing those structures in rural areas. So that is also kind of limiting its scope. So that's why it is not that much widely adopted till now. And also, like as we know that maximum farmers, they are marginal farmers, so it is also very difficult for them to actually continue with this biogas plants.
Okay. And what types of organic waste can be used in biogas plant?
Ma'am, organic waste, the first one is cow dung. The second one is this vegetable peels, like when we are using potato, the peels which we are collecting, that can be used. Then any sort of like feces, like it can be human excreta, it can be any sort of animal dung, animal excreta, and it can also be the other, like for example, this rice husk, like the waste materials of any plant, they can also be used in this organic material, which can be used to produce the biogas.
Okay. And can you explain the anaerobic digestion process in a biogas plant?
Yes, ma'am. Ma'am, so the anaerobic digestion is that, like as I already told you, that in this biogas plant, what we mainly do is that we take the semi-solid material and we obtain gas from those semi-solid material. So obviously, we have to think that we have to break it down again and again, again and again into simpler forms so that we can obtain the gas from it. So what is anaerobic digestion is that, like when we are putting this slurry, which is the mixture of cow dung and water, then so many complex compounds are there. For example, carbohydrates are there, then polysaccharides are there, so which is very difficult to be broken down. So what is done in this anaerobic digestion? So in absence of oxygen, the anaerobic bacteria and the organisms, they work upon these compound or these complex particles, and they break it down. Like for example, this polysaccharide is broken down into monosaccharides, which is a simpler form. So we break it down, or I mean, that is been broken down in that process, and that is further like broken down into so many steps, and then we obtain the biogas as the end product.
Okay. And what are the environmental benefits of using biogas as a fuel?
Ma'am, the major benefit is that the reduced carbon footprint. The carbon footprint is reduced. No synthetic or no this inorganic materials are used. So it is completely, like we can say that we are starting off in a very clearer way. Like no like synthetic materials are used. So it is also like environment friendly. We are also like walking into this sustainable agriculture as well, because we are using the organic material. Then again, we are using the sludge in our agricultural field, so that is also contributing to save our environment. And apart from that, it is also very much convenient for the environment, as everything is organic, like it is being obtained from the plants and the animal waste, so nothing is inorganic in this. So it is definitely like giving less carbon footprint and less air pollution.
Okay. And how can small scale biogas plants be implemented in local communities?
Ma'am, nowadays this the major, like some initiative governments should take, and even government is also taking this initiatives. They are launching some of the like they are also initiating people to actually form these biogas plants. And also the most important thing is that nowadays even self help groups, like the government, they are like very much supporting SHGs, like SHGs, like self help groups. So what is that? As I already told you, ma'am, that it's very difficult for any marginal farmer to install it by his own. So what can be done is that they can form a self-help group, that is a group of like 10, 12, 5, 7 farmers, and they can like together, like they can contribute and they can install this biogas plant, which can benefit the entire community, and which can also help the marginal farmers to come collectively together and to install these sort of biogas plants. Apart from that, also like people who are having a lot of land and a lot of bovines, like bullocks and cows, it is very beneficial for them to install it, because they are getting the raw material from their farm itself or from their home itself. And apart from that, obviously, if the marginal farmers, if they're coming together, if they are contributing together, if they're taking a loan and if they're constructing it, then it can benefit a huge sections of the society, and it will be more convenient.
Okay. One second. Yeah. What role does bacteria play in the biogas production process?
Ma'am, as I told before, also like the bacteria, they are the main. Like as I told that this is entirely a biological process. That means that living organisms are playing a very important role. So as I told that these complex particles, they are being broken into simpler particles. So entire thing are done by the bacteria. So these anaerobic bacteria, they are the ones who are actually breaking these complex particles into the simpler forms. For example, methanogens are there, then acidogens are there. These all are the bacteria that are helping in breaking down these complex particles again and again, so as to make it suitable to obtain the biogas.
Okay, okay, Miss Payel, I think 1 minute. Yeah, I think I don't see any more questions from our participants. And before we end, I have a last question. Um, can you let us know a little bit about your career background and what made you take an interest in this particular subject?
Yes, ma'am. Ma'am, so I am Payel Chatterjee. I am currently I'm pursuing BSc Honors Agriculture in Lovely Professional University, and I am currently in third year. So basically, I'm like my interest was in biology, and my interest was in this plants and this green life. So I've chosen this agriculture as my subject of graduation. So eventually, like we are having a very broad term of subjects. Like we are having a lot of subjects. Like we are having plant pathology, we are having soil science, and we are having entomology and so on. But what made me interested in this this biogas plant was basically a part of our soil. And when I saw this, like I thought that maybe I can, like my interest was mainly over this sustainable agriculture. Like I always wanted to contribute and wanted to see that how can I contribute to a sustainable agriculture. And even like my in my family background, like my grandfather, he's actually having a lot of farm under his area. So each time I, even when I visit my village area, I am always interested to see that what is going on and how the things are being done. So recently, before like 2.5 years, when I went there, like I saw that like even in village areas so much pollution is there. So the main reason is that like since advancements are also taking place in the village also, so now like previously people used to like burn the cow dung and all for the fuel purposes, but they have also started like the cylinders, the CNG, and using those things. So which is like indirectly it is affecting the our environment, and it is also impacting a lot in our climate change. So where, so now I like whenever I go to my place, it's like that the rainfall is not like that much good, or the soil is not that much proper. So then I thought that this is a thing which can be like a change is something which should be made from our own home. So then like when I came back to my home, when I got to know about these courses, so I connected with this course because this is something which I can implement practically. Like when I saw that the about the biogas plant, about the soil, that how we can convert the biogas from the raw materials. So I just went back to my village and I just discussed this randomly like with my grandfather, and then he was like, they never thought of these things. So then he thought, it can be done, like we can actually implement a biogas plant like initially. So then it could actually contribute. And I think that seeing him, maybe the other farmers, the other villagers, they will also come to know about this, because there are so many villages, ma'am, they don't even know what is a biogas plant, or they don't even know this concept that there is a plant which can actually convert the cow dung into something productive, or like we can actually like we can replace the cylinders with biogas. They don't have any idea as such. So when I talked to him, he was like, definitely he's going to see in future if he can implement one. And if at least not everyone, if I can start it from my own home, and if I can kind of influence people, or I can at least give the knowledge to people, and if even one people, if they start to do that seeing my grandfather, then I will think that I have contributed a lot in this. So that is how actually my interest began in this soil, and also in this mainly in this topic, this biogas plant.
Okay, okay. That's very good to know and very interesting story actually. So hope you get the required success in this particular subject and your further studies. So thank you, Ms. Payal, for the detailed presentation and answering all the questions with a lot of interest. And I also like to thank all the participants for joining this meeting. We'll close this meeting now.
Thank you, ma'am. Thank you to everyone who was a part of this meeting. Thank you.
You're most welcome. Thank you.